Hi everyone, in this video I'm going to present about my final year research project which conducted under the supervision of Associate Professor Dr. Lam Su Xiong. And before I continue, I'm Felicia Lau with matric number S41859. My research topic is production of value-added biochar and bio-oil from microwave CO2 pyrolysis of medium-density fiberboard waste. The problem or the motivation behind the study is the world's energy consumption is mainly supplied by the non-renewable resource such as fossil fuel that cause the high emission of greenhouse gas carbon dioxide. Therefore, using renewable energy such as bioenergy is essential to reduce greenhouse gases. Another motivation is the amount of MDF waste has been increasing, and its current disposal methods are either burned or landfilled, which can cause environmental issues. Hence, it is important to find a sustainable method to dispose MDF waste. The proposed approach is to use pyrolysis as it can convert waste into useful product, and in my study, microwave pyrolysis is used because it gives faster reaction rate, therefore shorter reaction time and lower power consumption. And also, CO2 is used as a carrier gas in this study as it could abate global warming that caused by a high CO2 greenhouse gas in the atmosphere. And in my study, microwave pyrolysis combined with CO2 was investigated for its feasibility as an alternative method for disposal of MDF waste. The three objectives in this study are to characterize physical and chemical properties of MDF waste, to determine the effect of CO2 and nitrogen in MDF waste microwave pyrolysis, and to characterize the physical and chemical properties of pyrolytic products obtained. Moving on to the methodology of the study. First is the sample preparation. The MDF was made into smaller pieces so that it can fit into the reactor. Second was the characterization of MDF by using TGA analysis. Lastly, the MDF was microwave pyrolyzed for different reaction time, 20, 30, and 40 minutes, under carbon dioxide and nitrogen condition. The diagram shows the microwave pyrolysis system that consists of a microwave and condensation apparatus. And this is how the real system looks like. Comes to the finding of the study. From the TGA analysis, it was found that MDF waste has a relatively high content of volatile matter 51% and fixed carbon 21%. The high content of volatile matter in MDF waste is a desirable component to produce bio-oil or biogas, which can be upgraded into a fuel or energy sources, while the high content of fixed carbon in MDF waste indicated that it is potential to be converted into biochar through pyrolysis process. Next, the figure shows the biochar production of CO2 and nitrogen microwave pyrolysis. For both the CO2 and nitrogen microwave pyrolysis, increase in reaction time increase the biochar yield, as longer residence time give a greater chance of repolymerization of biomass constituent. The biochar yield obtained from CO2 microwave pyrolysis is higher than it obtained from nitrogen microwave pyrolysis due to CO2 may enhance the defragmentation reaction to give a product that repolymerized to form biochar. Next, the figure shows the bio-oil production of CO2 and nitrogen microwave pyrolysis. It shows that increase of reaction time, the bio-oil was first increased and then decreased. Similar phenomenon was found in Rachel Tang's study, stated that this may be attributed to decomposition and repolymerization of bio-oil to gaseous product and biochar. Moreover, the bio-oil yield obtained from CO2 microwave pyrolysis is higher than nitrogen microwave pyrolysis due to CO2 might inhibit the thermocracking reaction of volatile, which resulted in higher char and liquid yields. And in conclusion, MDF waste was pyrolyzed under atmosphere of nitrogen and carbon dioxide using microwave pyrolysis within the reaction time range from 20 to 40 minutes. The study found that increase in reaction time would increase the biochar yield, but increase the bio-oil yield to an extent. And also, CO2 atmosphere would improve both the biochar and bio-oil yield. And microwave CO2 pyrolysis could be an alternative method for disposal of MDF waste. These are some of the references used in this study, mainly are the references that used in result and discussion. And that's all for this video. Thanks for watching.